I'm Doron from Switzerland. Really happy to be here. Thank you very much for the invitation. What I am going to talk about is today something that is often looked a bit as a niche, because in daily business we talk about disaster recovery, about restoring data, where we need performance and have a bit of, let's say, time pressure, if you know what I mean in this situation. But if it's not just about that you lose maybe a data center, or worst case, some storage system in the data center, you have a cyber attack, and then is exactly forensic the main topic. What I'm going to do is, I will show you a real-life use case. We will go through, let's say, the step. I show you something, or tell you something a bit about the customer. Then we go through 2 or 3 steps of the forensic process, are looking how object storage had an impact, and of course it was a positive one. And in the end, there is some lessons learned and some key takeaways that we want to I want to share with you from 2 or 3 such cases we had in the last 12 months, and especially from this customer, the last one that was the biggest. As I said, I'm Doron. I'm from DE&C. We are the first WASP partner in Switzerland, or we were the first in 2019. We built up this program. If you don't know it, in short, Veeam had a partner program for partners. So if partners needed help for post-sales or architectural or performance issues, all this kind of stuff, they can come to us, and we help them. And with this, we had, of course, a lot of interactions with customers, and especially in, let's call it, bad situations. So my point is a lot in the daily business about something is not working, and we now must bring it to work. This industrial customer, I cannot say any names, it's NDA, but in short, he's an industrial manufacturer. So he has a lot of facilities, highly connected. So I mean, everything is interconnected there. I would call it understaffed, but let's say a very small IT team there. And to solve this, they have everything highly automated. So under normal conditions, we would say automation is a good thing. If you're attacked, and this is maybe one part of it, it can be a challenge. They have some hundreds of millions of revenue. So you see, it's a big customer. And they have a few thousand, let's say, staff working for them all around in these facilities. I cannot share more than this, but it's from a real-life use case. So we cannot identify the customer, but we can take now a look on what happens from a real-life scenario. Let's say day null, day 0, or day X, or however you want to call it by the terminology. There was a simple alarm that was not really saying too much in the beginning. It only said that there is some data flow from a server out to the east, whatever that means. So the IT guys take a look on this server, and it was the R&D server, and they found out that there was a simple sync client installed, sending out data to somewhere in the east, and they found really fast out that it was data exfiltration. So in other words, somebody is stealing data from the R&D server. Okay, so in the first place, it's maybe a small thing, somebody installed a client, I don't know, maybe insider attack, something like this. So they called the external security team to help them, they deactivated the client, set up some firewall rules, and from their perspective, everything was good. And they called us, because we are responsible for the backup, to say, yeah, we need to find out who installed this thing, so kind of, we want to know what happened. So everything was good for about an hour, and then everything changed. So from an engineering perspective, when firewall rules change themselves, you have to start asking questions. And this is exactly what happened. In this 1 hour, the alarm went off again, and they found out that this thing started again. Firewall rules were changed, sync client was activated, and it was going on to take out data. And at this point, if you know what this means, you realize this is a full-scale cyber attack. If somebody has access to your firewall, to your network, and so on, it's not just somebody that installed the thing. Now you have to react. And of course, they took now not only the security team, but also added the forensic team and said, now it's a really simple challenge, simple in terms of the question is simple, but not what we have to do is we have to find out what really happened. The first thing you do in such scenarios, of course, the forensic and the security team cut off the internet, kind of nothing can go out or in again, and started asking questions to us as the backup provider. So now for finding the entry point, the first 2 or 3 questions that the security team from this external company asked us was, with all these, let's say, REAM repositories that you have there, are you sure that this data is all good? Kind of, it's not compromised in a way that it was changed. So it's not about good data or bad data, but about the truth. And we had to say, frankly, with still some Linux, Windows repositories they have, we don't know it, we cannot guarantee it. The only thing we can guarantee is now this object storage system with immutability that was isolated in a good way. This is the only source of truth that we know that we can guarantee that it's not compromised. And this pinpoints now to a single point where we can start now finding and looking for forensic. So normally you would have a bad situation because you have no idea if it's 2 weeks or 2 months or whatever the attackers were in. But a lucky, let's say, lucky punch was there that they really soon found out, let's say it was the firewall, 0-day exploit, 3 months ago, it was there. So 2.5 months was the installation. So they had already a point of time where they could say, in this range it is. And if you have been in such scenario, this is a really good starting point, because normally you have no clue. And in short, because we are not going really into the forensic part, but more about the technical and why object storage, in short, because it's a bit relevant to understand what we had to do, from the firewall, they attacked the Active Directory, from then the RP system to the R&D, so they made it through the whole network and made sure that they were everywhere in. They had even switches compromised, the firewalls were compromised, some edge devices, the VMs. So minimum 8 attack vectors were used to make sure that they are in. So if you you have somebody in your house, you close the door, they just open it again. And because they had already these entry points and they could follow some traces, they had the need for massive log files. So forensic is now doing the thing like you send log files, they're correlating it and finding out what happened. Who logged in to what system, with what account, what happened. And if you will hear now a lot of log files, you may already see where it goes with object storage. So reconstructing this path was, for them, the main work, and for us it was to deliver as fast as possible the files that they required to do their job. And if you know Veeam as an example, because it was with Veeam, the pattern is, if you write data or if you restore single files or even have an Active Directory user that you want to compare to the real-life system, it is a lot of small requests you do. And these small requests were thousands of files. It may sound like a marketing term, but as an example, there is the one server that correlates a lot of log files from different devices, and they were interested in yesterday, 6 o'clock, about 100 log files. Then 10 points in time later, the same thing, you had already 1,000 files just with one simple request from this forensic team. And this was now the challenge, or would be the challenge. And with the setup we had with object storage and with Veeam, and if you know how to operate it, it was just a simple task. A few minutes of waiting time, and we could say, there it is, prepared, go for it. What do you need next? And now comes the second thing that was really interesting to see. At some points, they wanted us to also restore some VMs so they could do other tests too. So it's not just getting out small files, but they also started to do it parallel, kind of a lot of VMs, a lot of files, to go more and more and more in the deep dive of what happened there. And short, let's say, keep it short, there was a few terabytes of files to get, for example, the ERP system. It was a lot of parallel processing, of course, but still they needed again and again thousands of small log files. This thing was going through 2 weeks of forensic and recovery, and in parallel. And now you see a bit, if I tell you this all small amount of files, for log files, for different systems, in different point in times, that with tape or even some data appliances, I don't have it on the slide, but I'm just telling you, it wouldn't work in this way. If you know how it works with tapes, I mean, it's sequential. You have maybe two stages somewhere. It would take, for the same task, we took maybe, I would say, let's say 15 minutes, or maybe even a bit less. It depends on how we were ready. It would take a few hours till maybe more. You have to get the tape, staging, and so on. And we talked afterwards to the forensic people, had kind of a debriefing also for us as a backup provider. What could we have done better? And it was for them not about what could be done better, but more about what was good, because we could answer all the questions. The question was, do we know which data is compromised? No, we don't know it, but we know which data is not compromised. So it's the immutable backup system. They have a single point of truth in this context. They need an amount of small files, so sequential read access. We could deliver it, and they are in time. And don't forget this, if somebody talks to you that maybe even with tape you need a few hours and you have the restore points there, it is not just one, it is about days. We are talking about 2.5 months that we had to go for one single server, the ERP system and the R&D server, for each day back in time to search for some log files. Or searching means more we just extracted and they did the correlation. So this was a huge amount of work that the systems did for us that we didn't have to do manually. This is why I'm pointing out. I'm not saying tapes are bad. I'm just saying for this use case with tape, this customer would have a really hard time. So this is nothing new that you will hear about immutability. I mean, for backup, for let's say ransomware attacks, it's exactly the same principle. Because you want to make sure that your data is in a state that you can say it is not changeable. And don't get me wrong, this morning I had a good talk to Valamir. He asked me the question, yeah, but you have to provide the clean data. And this is the difference to the backup, where you want to make sure that your backup are cleaned. For forensic, it doesn't matter. They want to have the point exactly as it was. And this is why also immutability is very important, because they want to know that you didn't change anything in the data there. So if you now just, let's say, add on top on disaster recovery, that you want to build infrastructure or, let's say, architecture that in the case that's not just disaster recovery, but an attack vector that you need, forensic, what you have to keep in mind to get there. So for the kind of investigate first and restore later idea behind it, as I said, it is more or less, in short, in a technical term, it's the same kind of pattern as Veeam has. So if your object storage system can handle these patterns, reading a lot of small objects, you're already in a very good state. And of course, immutability, as I said, I will not repeat it, but it's more or less also a slide for later. Don't forget that this is one part of it, and you have a second one. Let's say if you have Veeam, there are a lot of best practices how you should isolate your network, or how you should isolate Veeam, maybe not have it join into your main domain. And why I'm going into it is people often forget another key aspect. Let's say if here is forensic, you also need monitoring, because if you have no data in the system at all, they cannot help you. So this is one of a main point that I always tell in this, if it's about also immutability, don't forget to monitoring that you have the restore points on your system, that you have the backup in place, that the backup works. Because we saw in the last 3 years, I saw a few cyber attacks that the attackers before, as an example, also deactivated, or not just deactivated the backup, but excluded a lot of things so that the important data is not in anymore. And there I want to point out from our learning, because we are, this year internally, we built up a platform for, let's say, monitoring and forecasting to make sure what's going to happen, like that not only the data is going up and you have an alarm that your system may not perform, but also the way around, that something is not behaving like it should. And this is what I want to give you as a takeaway, that don't just take a look on disaster recovery, think about a team for disaster recovery, a part is forensic, and before it happens, and this is important, make sure that you have a good monitoring in place, that you know what you got. Because if you have the day 0 or day X, however you want to call it, then it's too late to do changes, because then it's already in place and you are there where you don't want to be. So I hope that you learned something about it, that you see why object storage is very important. And at this point, I want to say thank you very much also to Scality for our partnership, because this enables us to provide such infrastructure in Switzerland for our customers. Thank you very much, and enjoy the day.